We can organize and classify different acids by their strength. Strong acids will donate protons easily, and strong bases will accept protons more easily. On a data table, you can usually find the strengths of various acids organized by their Ka values. On the table used in Alberta's Chemistry 30 course, the 6 strong acids are found at the top of the table. Looking below, stronger acids with larger Ka values will be on the top left-hand side. That means as we move up this chart, the acids are becoming more strong. Oxalic acid is therefore stronger than hydrogen sulfide ions. On the right-hand side of the table, as we move down towards the bottom right-hand corner, stronger bases and smaller Ka values are present, so these are stronger bases as you move down the table on the right-hand side. A strong acid is defined as a proton donor that will completely ionize in water. All of the reactants are going to be consumed when a strong acid is present. It's a quantitative reaction where the products are going to be heavily favored. A strong acid will not form an equilibrium system. In this case, we have hydrochloric acid reacting with water, producing ammonium ion and chloride ions. And if we took a look at this in solution right here, we have hydrogen chloride, and since it's a strong acid, it's going to completely ionize. And when that happens, all of the ions are going to come apart, and we're only going to have ammonium ions and chloride ions existing within solution. The 6 strong acids that you need to know are listed at the top of that table, and there's 6, and they're all listed right here. You can tell they're strong acids because they have a very large Ka value, something that we'll talk about in the future. A strong base is defined as a proton acceptor that will completely dissociate, i.e. break up, in water. Again, all reactants are going to be consumed. It's going to be a quantitative reaction where the products are heavily favored. Again, a strong base, it's not going to form an equilibrium system either. So in the case of sodium hydroxide, it's going to dissociate and produce sodium ions and hydroxide ions. Taking a look at this in solution, what we'll see is this will completely dissociate and break up. And once this happens, we're only going to have sodium ions and hydroxide ions present within the solution. Weak acids, they will establish equilibrium in water and produce small amounts of hydrogen or hydronium ions. Not much of the weak acid will actually ionize, and in this case right here we have hydrogen cyanide reacting with water, and we see that an equilibrium system is formed. We have some of the products going to reactants and some of the reactants forming the products. If we took a look at this in solution, we will see that it would partially ionize, and that some would break up, and we would have all species present within solution. Weak bases, similarly, will also establish equilibrium in water and produce small amounts of hydroxide ions. Not much of the weak base will actually dissociate.